Hello everybody, this is Mr. Strager, and welcome back to another Big Ideas lesson. Today we're on lesson 3.4. We're about halfway done with Unit 3, a little bit more. But before we actually talk about the lesson itself, I want to do a quick activity with you. I'd like you to please take out a separate sheet of paper, and I want you to draw this on it. This should look very familiar to most of us. It goes by many names. Some people might call it a coordinate grid. You're going to hear me refer to it as a Cartesian plane. It's just a fancy way of saying your x and y axis. As a reminder, our x-axis is the one that goes from left to right, and it tells us how far left or right something is. The other axis we call our y-axis, and it tells us how far up or down something is. So let me give you an example. Let's say I had a point, and that point was right here. If I wanted to say where that point is located, there are two things I need to write down. I need to write down, first of all, how far left or right it is, then how much up or down it is. Well, if we start from going left to right, it's 1, 2, 3, 4 units to the right. That means when we write out the point, the first thing we're going to write down is going to be the number 4, our x-coordinate. The x-coordinate, again, just tells you how far left or right you go. But the second thing we need to figure out is how far up or down it goes. Well, it doesn't. It sticks around on the x-axis. It doesn't go up or down. So we would put this as 4, 0, and the 0 shows us that we didn't go up or down. Here's a question for you. Based on this point alone, do I know what a line that I want to make would look like? Again, if I wanted to make a line based off of this point, do I know what that line looks like yet? The answer is no. I might have some guesses. My line could go through the point and look like this, or it could look like this, or it could look like this, but we're unsure about what exactly it'll look like. In order to make a straight line, you always need at least 2 points. Once you know 2 points, you have enough to make a line through it. So let's add another point in here. Let me add this one right here. What are those coordinates? Well, again, we've got to ask ourselves how much left or right is it, and then how much up or down is it. So in terms of x, it doesn't go left or right. It only goes up. So since it didn't move on the x-axis, we say that the x-coordinate is 0. And how much up or down did it go? Well, it went up 3. So this is our point, 0, 3. Now do we have enough to draw out our line? I believe we do. Once we have 2 points, that is enough to draw out a line. So I'm just going to use a straight edge, just an old piece of paper from a previous lesson, and I'm going to draw a line right through both of those points. And this is my line. Nothing too crazy. When it comes to section 3.4, we are going to be focusing on how to make these lines, but also one very specific aspect about these lines. Do you notice anything unique about these 2 points? You might have noticed that both of them have a 0 coordinate. It's because they're on the axes, right? We actually have very special names for points that are exactly on our axes. We call them intercepts. So this dot right here intercepts our x-axis, right? It's where the line goes through the x-axis. Because of that, we call it our x-intercept. On Big Ideas, you might be asked to find what is your intercept. What they mean by that is, what coordinate does it pass through the axis at? Well, I mean, it passes through 0, but that's a given. If something's on the axis, of course it's going to be some measurement of 0. Something that's on the x-axis doesn't go up or down. So that's why our y is 0. When it asks for your coordinate, it wants this number here. So we could say our x-intercept is 4. In other words, our line crosses the x-axis at x equals 4. This up here we will call our y-intercept for the same reason. It crosses through the y-axis. And it crosses through at y equals 3. So our y-intercept is 3. The most important thing for this lesson is that when you have something that crosses through your axis, one of your coordinates is always going to be 0. Since our x-coordinate, or sorry, our x-intercept doesn't go up or down, y has to be 0. This will be the same for every single intercept. There is always going to be a 0 coordinate. And for every x-intercept, that y is 0. For our y-intercepts, we never move left or right. Even if our intercept was up here or down here, we don't move left or right. So we say that our x equals 0. This property is going to make things extremely handy for us in the near future, so keep that in mind. Alright, I think it's about time we take a look at our notes real quick. We fill in a couple definitions, but we'll come back to this paper in just a little bit. So, on page 76, there are 3 definitions. Standard form, we're going to just write down the definition for, but we're not going to talk about it just yet. X and Y intercepts, though, we kind of already know the definitions, which is nice. The definition of standard form is this, and it's going to be a little weird. It's going to be a certain type of equation for a straight line. But it's not going to be the one we're used to using. It's not going to be y equals mx plus b. That's going to be in the next section. Standard form is a way of writing out a formula for a straight line that deals with just the intercepts. The formula is capital A times x plus b times y equals c. Again, it's a little bit confusing right now, but don't worry, we'll talk about it in a little bit. The most important thing to note is A, B, and C are real numbers, and the most important thing, A and B do not equal 0. Alright? Let's now move on to the definitions of x-intercept and y-intercept. The x-intercept is the point where a line crosses the x-axis. And what was the key thing we noted about that? About the y-coordinate of an x-intercept? Well, that it's going to be 0. It doesn't go up or down. The opposite is true of a y-intercept. It's the point where a line crosses the y-axis. And what's true about the y-intercept? Well, we don't know what its y-coordinate is. It could be 3, it could be -2, it could be 20, but we know our x-coordinate is going to be 0. Keep this fact in mind, because this is the most important thing from this lesson. The next thing we're going to be talking about is horizontal and vertical lines. The notes are right here if you would like to take a look at them, but I'm going to try to explain it graphically. So let's say we drew out another Cartesian plane. On this Cartesian plane, we're going to try to figure out the equations for some lines. I'm just going to draw a couple of tick marks here so we know precisely what the units are here. There we go. And you can just assume every tick mark is 1 unless it's stated otherwise. So let's say, for instance, that I have a vertical line that looks like this. And of course, it passes through the x-axis right here. And I want to write out the equation for this line. An equation is just a way of representing a line, right? We want to represent this line the best we can so that anybody in the future looking at that equation could make this exact line. Well, what do we know about this line? Well, we know the X-intercept is at 3, 0. Do we know about any of the other points on it? Well, sure. It seems to cross through here, which is at 3, 1. And it seems to cross down here at 3, -4. And here, and here, and here, and here. What's common to all of these points? Every single one of them has the same x-coordinate. X equals 3. It turns out that for this particular line, that's the name of the line, x equals 3. And if you tell somebody to graph x equals 3, this is what it's going to look like. It's a little bit weird, but think about it like this. If we're just told x equals 3, but we're not told about y, it means y could be anything, right? X equals 3, y equals 0. X equals 3, y equals 1. X equals 3, y equals -4. Since our y could be anything, the line shows everything along that y. The line x equals 3 is just the line that crosses through our x-axis at 3. And note that there is no y-intercept for this line either. Alright, let's try one more. Let's say we had a line crossing through like this. Well, again, we got to ask ourselves, what's our intercept here? Well, it's a y-intercept since it's on the y-axis. It's right here. And this time the y-intercept is, remember that our x is 0, our y is down 4, so it's -4. And again, every point on this line is going to have that y coordinate. For instance, this is -3, -4. And over here, it's 2, -4. So the big unifying idea for this blue line is that y equals -4. So that's the equation. If I just told you that y equals -4, you would be able to graph this line. On page 77, we actually talk a little bit about this, at the very bottom of page 77. And there are two problems here. I want you to try out these two problems. They should be really quick, but remember, plot your intercept first. Then you'll know how your line is going to look. Pause the video here, and let's see how we do. How we do? So as we look at these, we have to keep in mind, y equals -3 tells us that our y-intercept is -3. That's where our y-intercept is. So our line is going to be the line that goes straight through that intercept. Everything along here is at y equals -3. If x equals 2, that tells us our x-intercept is at +2. So everything that goes through this line will have an x-coordinate of 2. All right, let's quickly flip back to 76, where we talked about this standard form. Standard form is a way of writing out the equation of a line that isn't vertical or horizontal, in a way that tells us what the intercepts are. What you will not be asked to do is you will not be given a graph and asked to write out the standard form. Not just yet. However, I'm going to tell you that for this graph we did originally, the equation in standard form is 3x plus 4y equals 12. Again, don't worry too much about specifically how I got every single thing in here, but I do want you to take a second and try and see what you notice about comparing this equation here to this graph here. What are some things you notice? Well, some folks might mention, I recognize the 3 and the 4. They're right here in the equation. But the 4 isn't with the x, it's with the y in here. And our 3 isn't with the y, it's with the x. So it's sort of flip-flopped. The other thing to keep in mind is this 12. Some keen-eyed viewers might recognize that this 12 might have come from multiplying our 3 and 4 together. We'll talk about that in a second, but that is absolutely correct. Again, you won't be asked to find an equation in standard form from a line. You're going to be asked to do quite the opposite, which is to draw out the line based on the standard form. So here's the idea. If we have this equation, and I wanted to solve for my y and x intercepts, of course we already figured it out over here, but let's pretend we didn't know that. Here's how we would go about solving this. Remember that key piece of information about the x-intercept. For our x-intercept, what piece of information are we guaranteed to know? Well, we're guaranteed to know that y equals 0. If y equals 0, can we plug that into this equation? And the answer is yes, we can. If we know that y equals 0, we end up with the equation 3x plus 4 times that 0 that we would plug in equals 12. And what's 4 times 0? Well, it's 0, so it cancels out. All we're left with is 3x equals 12, and I think most of us know how to solve this. To solve for x, we would just divide by 3 on both sides, giving us x equals 12 divided by 3, which is 4. So our x-intercept is 4. Okay, but how do we find the y-intercept? Well, it's very similar. We only really know one thing for sure about our y-intercept. It's part of what makes it a y-intercept. And that's the fact that its x-coordinate equals 0. So what can we do with that? If we know x is 0, let's plug it in for x. So again, the equation is 3x plus 4y equals 12. And since we know x is 0, we put a 0 where x is. Now it's 3 times 0 plus 4y equals 12. And what's 3 times 0? Well, that just ends up being 0. So we end up with 4y equals 12. And to solve for y, it's very similar. We divide by 4 on both sides, giving us y equals 3. So our y-intercept is 3. This is how we would solve these problems. If we're trying to find our x-intercept, our y becomes 0, and it cancels out. If we're trying to find our y-intercept, our x becomes 0, and it cancels out. This is how we can use a little bit of a trick I like to call the thumb trick. I want you to take your thumb, physically, and if you're solving for the x-intercept, you're going to cover up your y term. Whatever's left over, you're going to solve. So we could solve 3x equals 12. Notice that that's what happened down here. When this canceled out, we were just left with 3x equals 12. If you're trying to solve for the y-intercept, it's the same thing, but now if we're trying to solve for y, our x becomes 0. So we're left with 4y equals 12. And lo and behold, 4y equals 12. This thumb trick is what makes standard form one of the fastest ways of graphing. All you need to do is figure out each term one at a time. 3x equals 12, 4y equals 12. Let's try this practice out on problem number 5 on page 78. So here's what I want you to do. I want you to try out number 5 on your own. I want you to try this thumb trick. Remember, if you're trying to find your x-intercept, cover up your y term. If you're trying to find your y-intercept, cover up your x term. We'll come back in a second and we'll talk about the answer. So pause the video and try this out. Alright, hopefully you've had a chance to try this one out. Let's talk about the solution. So, if we're trying to find our x-intercept and our y-intercept, what we really want to do is we want to figure out each piece individually. To figure out our x-intercept, we know that the y is 0, so this entire thing will cancel out. That's where we would cover up our negative 2y term with our thumb and solve what's left. So the equation we're trying to solve is 5x equals negative 30. 5x equals negative 30. Well, how do we solve this? Since it's 5 times x and we're trying to get x by itself, we really just divide by 5 on both sides. Negative 30 divided by 5 is negative 6, and 5x divided by 5 is just x. So our x-intercept is negative 6. Let's repeat this trick for the y's. So, if we're looking for our y-intercept, we cover up our x term. That gives us negative 2y equals negative 30. Well, how do we get y by itself here? Again, we divide both sides. This time it's by negative 2. Negative 30 divided by negative 2 is 15, so y equals positive 15. Those are our two intercepts. This is going to be extremely helpful when we are graphing. So if we take a look at question 6, for instance, we can use this to extremely quickly graph this. Let me show you what I mean. Let's find the x-intercept first. To find the x-intercept, we cover up the y. Negative 8x equals 24. If you want to solve this on the sides, you can. You can absolutely write out negative 8x equals 24 and solve. But some of you might be able to figure this one out in your head. Divide both sides by negative 8, and you get negative 3 is your x-intercept. If we're trying to find our y-intercept, we end up with 12y equals 24. And what times 12 is 24? 2. So just like that, we have our line. And it's going to look a little something like, well, I should use a straight edge here, but I am going to be freehanding this one. It's not too bad. Like this. That's how quick it is. If you know how to multiply in your head, this is just extremely quick. Of course, it wants you to label the points too, so you would write out negative 3, 0, and 0, 2. But we're done. Let's try it again with this one. Let's see how quickly we can do it. To find our x-intercept, we cover up the y. 2x equals 4. What times 2 is 4? 2 times 2 is 4. And here we just have y equals 4. That's kind of convenient. Bam, our line is done. No need to figure out the slope, no need to figure out pretty much anything that we would traditionally need to figure out when finding a line. That's it. The last question in your notes is a word problem, and you will see word problems like this. First things first. The school band is selling sweatshirts and baseball caps to raise $9,000 and attend a band competition. Sweatshirts cost $25, baseball caps cost $10. This is the equation that models the situation, where x is the number of sweatshirts sold and y is the number of baseball caps sold. So if we look at just the 25x, for instance, that's $25 times the number of sweatshirts. 10y is $10 times the number of baseball caps. And this 9,000 is the 9,000 they're trying to reach. So we're asked to find and interpret the intercepts. Well, we know how to find the intercepts just fine. We'll talk about how to interpret them as well. To find the intercepts, we cover up the other term. So for the x-intercept, we have 25x equals 9,000. And if we divide both sides by 25, we'll know what our x-intercept is. Let's try it out. So 9,000 divided by 25 is 360. So x equals 360. When it asks to interpret, what it's really asking you to do is it's asking you, what is x? Well, our problem will tell us. X is the number of sweatshirts sold. So x is 360 sweatshirts. If we sold 360 sweatshirts to get to $9,000, how many hats did we sell? Well, think about it like this. If our equation was just 25x equals 9,000, that means that all we sold were sweatshirts in order to get to 9,000. This would be a case where we would have 0 caps. That's where the 0 comes from on our graph in a word problem. It means we sold 360 sweatshirts and 0 caps. Let's try the y-intercept. To find y, we look at our equation and we cover up the x, giving us 10y equals 9,000. And some of you might be able to figure this one out because dividing by 10 is fairly simple. If we divide by 10, it's the same as just getting rid of a 0. So we end up with y equals 900. What does y represent again? Well, it's the number of baseball caps sold. So this would be the case where if we sold 900 caps, and how many sweatshirts would we sell in this situation? If we got to $9,000 from just selling hats, it means we sold 0 sweatshirts. In these interpretation problems with the intercepts, you'll solve for one variable. The other variable will be equal to 0. So if x is the number of sweatshirts and y is the number of baseball caps, one of them is going to have a number, the other is going to be 0. This question here is a little bit tricky. If 258 sweatshirts were sold, how many baseball caps are sold? I want to go on a separate sheet of paper for this one. The idea, though, is this. We have our equation, which is 25x plus 10y equals 9,000. What are they telling us here? If they're telling us that we sold 258 sweatshirts, what are they really giving us info about? Well, it tells us that x is 258. That's how many sweatshirts there are because the number of sweatshirts is x. X is the number of sweatshirts sold. So what it's saying is to plug 258 in for x and figure out what y is, our baseball caps. In doing this, we would end up with the following equation. It'd be the same thing, except we would put 258 in for x. Now we just need to solve this. It can be a little bit tricky at first, but the key to remember is this is just a multi-step equation, where you should simplify everything you can, and then use reverse PEMDAS to solve for our missing variable, y. So first things first, what's 25 times 258? Well, we do it in our calculator. We get 6,450. So 6,450 plus 10y equals 9,000. There are two things attached to our y. We're multiplying by 10, and we're adding 6,450. So we have to ask ourselves, which do we get rid of first? Well, according to reverse PEMDAS, we want to get rid of this addition first by subtracting. These ones cancel out, leaving us with just 10y on this side. I'll write that in red so we remember what variable we're solving for. And 9,000 minus 6,450 is 2,550. Well, all that's left to get rid of is this 10, so we divide by 10 on both sides, keeping in mind that dividing by 10 is the same as removing a decimal place. So it would be the same as just putting our decimal right there instead. Our answer is y equals 255. 255 what? Well, x is the number of sweatshirts, y is the number of caps. So that's the answer to 8b. We sold 255 caps if we sell 258 sweatshirts. Part C is a little tricky. It says to graph this equation and then find two more possible solutions. When you're graphing something that the numbers aren't like 1 through 10, you need to decide on the scale. In other words, you need to decide what numbers to put down here. Your scales don't need to be the same on the y and the x. It'd be cool if they were. But the most important thing is that you can fit both your points using this scale. So ask yourself, what's the highest x we get to? It's 360. So whatever we pick, we have to pick numbers on this axis that'll fit 360. Now, if you want it to be as optimal as possible, you could divide 360 by 10 to figure out exactly what each of these lines should be, and your point will be here at the end. You don't need to be that precise. Just pick a number that your intercept will be exactly at one of these tick marks when you count up. I'm going to choose to count up by 60s. So 60, 120, 180, 240, 300, 360, 400, 420, 480, 520, there we go. 540, 600. So our X-Intercept, we said, was 360 sweatshirts and 0 caps. So we put a dot right there at 360, 0. On our y-axis, the number of caps that's our intercept was 900. 900 caps was our y-intercept. So let's count up by 100s. 100, 200, 300, 400, 500, 600, 700, 800, 900. 900 be all the way up here, so we have enough to make our line. It is key that with these types of problems, your line is as straight as possible. So I'm going to, again, use a straight edge. It could be a separate sheet of paper, it can be a ruler, it could be a yardstick. Whatever is a good straight edge. You could use the side of a binder. It is all up to you. The key here is it asks us to find two more possible solutions in the context of the problem. Remember that this line shows us all the possible solutions. So all we need to do is figure out some more points that are on this line. To figure out more points on the line, I'm going to zoom in for this one. You just need to figure out where the line crosses through an exact place. You can do that visually just by looking. I see that it seems to cross through at this point here and this point here perfectly. The points you choose may be different depending on your scale. So, what are these coordinates? This point here, if I could look down, its x value is 120, its y value is 600, so it's 120, 600. This point here, if I look down, it's all the way down at 240 and 300. So it's 240, comma, 300. But it doesn't just want these solutions. It wants it in context. If we look at the context of the problem again, we're talking about X is the number of sweatshirts and Y is the number of baseball caps. So if we're looking at the point 120, comma 600, which one is the X and which one is the Y? And what do they mean? Well, 120 is our X. So 120 shirts, and since 600 is our Y, that's 600 caps. The other solution that we found was 240, 300. If we have the point 240, 300, we got to ask ourselves again, what's the X and what's the Y? Our X is always the first number, so that's the number of sweatshirts. 240 shirts, comma, how many caps? Well, that's our Y, 300. 300 caps. That is how we can figure out how to graph in standard form. Alright everybody, thank you so much. If you have any questions, let me know. Otherwise, I will see you next time.